All right, for number 1, it says find the tangents of the acute angles in the right triangle. Write each answer as a fraction and as a decimal rounded to 4 decimal places, okay? So our 2 acute angles are going to be S and what? R. Good. Let's start with the tangent of S. Any ideas what the tangent of S is going to be?
10 over 26.
Very good. 10 over, why is it not 26?
Okay, no, 10 over 24.
Okay, why not 26 and why 24?
Because 24 is the side of the right angle.
Okay, and what do we call that, Marcos? Do you remember?
No.
Who remembers what we call those? The ones that form the right angle?
The hypotenuse.
No, that's the one that doesn't form the right angle. It's the leg, right? Did anyone say leg? Okay, remember, these 2 are our legs. This one is our hypotenuse. Why is it the hypotenuse, people? It's opposite what? The right angle, okay? Your hypotenuse is always going to be opposite the right angle. The other 2 that form that right angle are your legs, okay? So we go opposite our angle, S, to give us the 10, which goes in the top. And then we use the adjacent leg, or the leg next to our angle, to form the denominator, 24, okay? Now, if we take 24 and we divide it, or we take 10 and we divide it by 24, let's see what we get. So go ahead and pull out your calculators. You're going to need them for today's lesson. Let's clear everything, and let's do 10 divided by 24. That gives us 0.41666, repeating. So if we rounded this, it would be 0.4167. Why did I round there? Very good. Make sure you're reading the question, okay? Round to the nearest, or round to the 4 decimal places, okay? So I go over 4 places, 1, 2, 3, 4, so I'm going to round to that number. It was a 6 and a 6, so the 6 gets rounded up to 7, okay? All right. Always on your test, guys, it will tell you what to round to. So I had a lot of questions on what do I round to, what do I round to? If it doesn't say, okay, round to 2 decimal places. But on your test, it will tell you explicitly what to round to, okay? All right, the tangent of R. (24 over) not 5. What is it, Kevin?
I thought it was 24 over 5.
It's not 5. What is it?
10.
10. There we go. Where'd you get that 5 from, Kev?
I don't know.
Now, if we were to reduce this fraction or simplify the fraction, right? This would actually be 12 over 5, okay? We could divide both the top and the bottom by 2. Do you see that? But other than that, I don't know where the 5 came from, Kevin. It's okay, though. Okay, so then we take 12 divided by 5, and we have to round to the nearest 4th, or the 4th decimal place. So switch back over to your calculators. Let's do it. We're doing 12 divided by 5, and we get 2.4. That's our answer. Okay, questions on number 1. Why is the tangent of K not equal to 24 over 32?
Because it's in the wrong order.
What order should it be in?
32 over 24.
There we go, okay? K is right here, right? Opposite the K is the 32, so this one's our numerator, and this one needs to be our denominator. So this tangent of K is actually equal to 32 over 24. So this, the order of this was our error. This is how it's supposed to look. Why don't we use the 40?
Because the hypotenuse is not adjacent to K.
Very good. It is our hypotenuse. We don't use the hypotenuse for tangent. Okay? Any questions on either of these? Ask now, people. In this lesson, guys, we are going to be talking about sine and cosine, okay? They work just like tangent, but they're just slightly different, okay? So when we talk about sine and cosine, okay, those are also going to be ratios of two of the sides of your right triangle. But they no longer are just going to be the legs. Sine involves the opposite leg and the length of the hypotenuse. Cosine involves the leg adjacent to your angle and also the length of your hypotenuse. So we can see this more clearly, I want you guys to take out a highlighter, pick any color you want, and highlight the first statement in sine, the length of the leg opposite angle A. And then looking at our diagram on the right, can anyone tell me what is the segment or the side that's opposite angle A? BC, very good, okay? So go ahead and highlight that side in your diagram, BC. Good. Use the same color for that. All right, now, can anyone tell me what is the hypotenuse? So go ahead and highlight the hypotenuse in a different color, length of the hypotenuse, and we need to highlight it on our figure. What is the hypotenuse in our figure? AB, very good. So highlight that one in the same color. Why is it AB? Why is the hypotenuse AB, guys? It's what? I can't hear you, David.
The longest side.
It's the longest side. What else could we use to identify the hypotenuse?
It's facing away from the right angle.
Very good. It's opposite that right angle. Our right angle is right here, right? It's the side that's opposite the right angle. Excellent. Okay. So we're just going to use that same highlight. So whatever color you used, and highlight the length of the hypotenuse for cosine. Okay. So sine we already identified would be the length of the leg opposite the angle over the length of the hypotenuse. Cosine is going to be the length of the leg adjacent to A over the length of the hypotenuse. So pick a different color for highlighting and highlight the length of the leg adjacent to angle A. What is that segment? What is the leg adjacent to angle A? Leg B, very good. Or AC, excellent. It's right here. Good. Okay, and then it gives you all the ratios of all of the angles down below. So if you look at the sine of angle A, sine is opposite over hypotenuse. So it was a over little c. Cosine of angle A is the adjacent leg, which is little b, over the hypotenuse, which is c. Can anyone tell me what's the big difference between sine and cosine and tangent? What's the big difference, Noah? Very good. In tangent, we never use the hypotenuse. For sine and cosine, we use the hypotenuse for each of them. Okay? Awesome. All right. Now, you guys are probably like, Mr. Jericho, how on earth are we going to remember all of these crazy things? Okay? That's where the phrase SOHCAHTOA comes into play. Okay? SOHCAHTOA. I need you guys to, right now, draw a line between the H and the C and the H and the T. SOHCAHTOA. You're going to hear me say it a million times before your chapter test. And what this means is, it's just a way to remember that sine, so this S is sine, is the opposite over the hypotenuse. Sine is opposite over hypotenuse. So when we write it, it would be sine equals O over H, or opposite over hypotenuse. That's the SO of SOHCAHTOA. S-O-H. Okay, now C-A-H is our second one. What do you guys think the C stands for? Cosine, very good. So let's fill in cosine. The A now is going to stand for adjacent, because it's the adjacent side. And the H stands for, what do you guys think? Hypotenuse. Okay, so how we write cosine is cosine equals A over H, ca in SOHCAHTOA, and this is adjacent, over hypotenuse. And our last one, tangent. T stands for tangent. O stands for what? Opposite. And A stands for adjacent. So tangent is the opposite over the adjacent, or O over A. BC, and that length is? 3. So let's go ahead and fill this in. This is going to be the opposite, which is 3, over. The third letter in SO is H. So we have to find the hypotenuse. What is the hypotenuse? 5. Excellent. So our sine of A is 3 over 5. Let's find the cosine of A, okay? In cosine, we're looking at CAH for ca, so we're here. We need to find the adjacent leg. Good, it's 4 over the hypotenuse, excellent, which is 5. and the tangent of A. So tangent, we need to look for the opposite over the adjacent. And in tangent of A, what's opposite angle A? The 3. And what's the adjacent leg? 4. 3 over 4. So remember, if you are confused about, oh, how is he getting these, okay? Start at your angle. If it's adjacent, remember, you want to pick the adjacent leg, in which case this is 4. If it's opposite, just go completely opposite your angle and find that side, which is 3. And if it's the hypotenuse, you should be able to identify your hypotenuse based on the fact that it's a right triangle. Okay, let's take a look at B. B is asking us for the sine, cosine, and tangent of angle B. Okay, remember, let's use SOHCAHTOA again. SOHCAHTOA. So sine is going to be opposite over hypotenuse. We're using the O and the H for sine. What's the opposite of angle B? 4 over 5. Cosine of B is going to be adjacent over hypotenuse. Adjacent over hypotenuse. We got that from ka in SOHCAHTOA. So, what is the adjacent side or the adjacent leg to angle B? 3 over the hypotenuse, which is 5.
I have a quick question.
Go ahead.
For tan A, why was it not 4 over 3? Because isn't it opposite over adjacent?
Yeah, because angle A, right? What's opposite angle A? Do you see how it starts with the opposite? Watch what tangent of B is, okay? So tangent of B is going to be opposite over adjacent. What's opposite B, Teresa? The 4. This is where the 4 goes in our numerator, okay? So this is going to be 4 over what's adjacent. What's the adjacent leg to angle B? 3. Good. Okay, are we starting to see it a little bit better now? Okay, we still have 2 more examples. SOHCAHTOA. Elisa, you with me? You with me?
Yeah, I'm actually kind of getting it.
You're kind of getting it? Good. Alexandra?
Yeah.
Okay. Samantha?
Yeah.
And Kale. All right, cool. Let's check out another one. One really cool thing about sine and cosine is that whatever you find the sine of, if you take the cosine of 90 minus that angle, you're going to get the same result, okay? Same thing works in the other way. So if you take the cosine of an angle, you take the sine of 90 minus that angle, and you're going to get the same result. So let's take a look down below. We're going to skip this for now. Example 2, okay? Let's use a calculator to find the sine of 30 degrees, the cosine of 42 degrees, and you guys can cross these out. We're not going to do these two, okay? The sine of 30. Well, if we're following that same logic, the cosine of 90 minus 30 should be the same thing. What is 90 minus 30? Okay, so let's plug it into our calculator. Let's see if we get the same thing for the sine of 30 and the cosine of 60. Go ahead and switch over to your calculators, and let's plug both of those in. So let's plug in the sine of 30. Press enter. We got 0.5. Fill that into your notes. 0.5. And then let's find the cosine of 60. 0.5. Okay, the cosine of 42 degrees. That should be equal to the sine of 90 minus what? (42). And 90 minus 42 is what? 48. So let's check it out. Let's see if this still holds. Let's find the cosine of 42. Let me show you guys. Cosine of 42, I got 0.743. Let's round to 2 decimal places, 0.74. And then let's do the sine of, was it 48? 0.74. It's the same, right? So both of these are equal to 0.74. Okay, last thing that I'm going to leave you guys with. Okay. Jump to example 3. We'll go back to the other two. We're not skipping them, okay? But we're going to jump to example 3 because that pertains to what we just learned. Okay. Find the values in x and y to the nearest integer. Okay, so we're going to round to the nearest integer. All right, so we've got a triangle, a right triangle set up here, okay? And we're given an angle, and we need to figure out, okay, how can we use that angle to figure out x and y? Well, let's look at the 28 degrees as the angle, and let's go opposite that angle. What did we just hit? What side did we just hit? X. So we know that if we're talking about the sine of 28 degrees, remember, so, SOHCAHTOA. The sine of 28 degrees is going to be the opposite over the hypotenuse. In other words, this is what's opposite the 28? X over, and what's our hypotenuse? 1,000. So we have sine of 28 degrees equals x over 1,000. Do we know how to solve this?
Did Nicholas Bisbal get to class?
No, he is not in class.
Is he on Zoom?
Let me check. No.
No.
Oh, he is. Yes, he is. He's here. Hopefully she heard me. We're going back to it, Reynold. Okay? All right. How do we solve for x, people?
Multiply each by x.
Not by x. By 1,000. Why do we multiply by 1,000? Say it again. Guys, I can't hear you. Can you speak up? Is anyone saying anything? No? Why do we multiply by 1,000 and not by x?
To single out the variable.
Very good. We want to cancel something, right? We don't want that denominator over there. So we're going to cancel these thousands. And we're going to get x equals...
Nicholas Visball. Nicholas Visball. Please report to Student Services. Nicholas Visball to Student Services.
Nico, I'll take care of it.
Hello?
Nico is on Zoom. My apologies.
Oh, okay, thank you.
Okay, so we take the 1,000, we multiply it by the sine of 28 degrees, and this is where our calculators come into play, okay? Because we don't know the sine of 28 degrees. No one in the world knows it unless they're using a calculator, okay? So let's switch over to our... From the last problem, who remembers how to solve this? Multiply by 1,000. Get rid of that denominator. So y is going to be 1,000 times the cosine of 28 degrees. When we plug that into our calculator, let's see what we get. So switch over to your calculator. Plug in 1,000 times the cosine of 28. You should get, hopefully you guys are plugging this in because this is good practice, 882.94759, something along those lines. And we are going to round it. If we rounded it to the nearest integer, what would our final answer be? 883. Remember, since the 9 will force the 2 to round up, so we would write it as 883.
How come we didn't do that to the other one, 469?
Because the number, it was 469.4, and 4 does not round up, right?
Oh,
Okay, so if it's a number 5 or greater, you're gonna round the number next to it up. If it's a number 4 or less, you're gonna keep the number the same. It's gonna stay the same. So this was 469.4. So this isn't gonna round it up. It's just gonna round it down to 469. Now I agree, Teresa. If this was 469.5. then yes, it would round it up.
I thought it was.
It would be
so
470.
that's why-
Okay?
For the test, if we mistakenly left for example, if we put 88.2.9, would it be marked as wrong or
It wouldn't be marked as wrong, but you would get a few. So looking at this example and what's given, okay? We're going to take x degrees and we're going to use a trig function, either sine, cosine, or tangent, to use those two sides that were given. What do you think we need to use? Sine, cosine, or tangent?
Sine.
Why? Very good. Why is it sine?
Because if you use sine, you can use the x and the 30 because it's opposite over hypotenuse.
Good. We can use the 18 because it's opposite. And then this is our hypotenuse, right? So we have opposite and hypotenuse. That's SOH. So this is O over H, which is 18 over 30. Okay, so now we have the sine of x equals 18 over 30. Yes. So this is gonna be what? What's that? 3 over 5. Good. Because you divided by what? Good. Now remember, I told you guys I would not ask you to find the sine inverse of this. You would just leave this as your answer. The sine of x equals 3 over 5, okay? So I wouldn't ask you to find x. I would say find the sine of x, okay? Or what trig function would you use to solve this? And it would say, and you guys would have to recognize, okay, I know the opposite and I know the hypotenuse. So I would do 18 over 30, and then I would write the sine of x equals 5 over 3.